All right, gang, this is going to be a video of me working through the quiz questions for chapters 3 and 4. So let's get started. So question 1, Molly is a licensed social worker who does talk therapy in Durham, specializing in college students, blah, blah, blah. She finds that when she charges $100 an hour, she gets 60 clients. However, when she reduces her hourly charge to $80 an hour, she gets 100 clients. The inverted demand curve for Molly's services is, okay, so what do we know? Well, we know that for option 1, the price is 100 and the quantity is 60. For option 2, the price is 80 and the quantity is 100. So an inverted demand curve, as we have discussed in class, looks like so, with price and quantity here and here. It's inverted because because a normal demand curve would have Q as P as a Q as a function of P. We invert it so that P is a function of Q, meaning P is in the y-axis. So we're going to treat P like it's in the y-axis. So that means that this is y and this is x. Okay. And so we have now, we're going to try to calculate the formula for this line. That's basically what this is asking, as P is equal to some intercept A minus some slope times Q. So we want to figure this out. So the first way the first thing we're going to do then is figure out what the slope is by doing M equals y1 minus y2 over x1 minus x2. So P is our y variable, right? So P1 is 100, P2 is 80, x1 is 60, and x2 is 100. Now, this is a downward sloping line, so we know that this has got to be a negative number. So if we don't get a negative number, we know we did something wrong. So 100 minus 20, minus 80 is 20. 60 minus 100 is minus 40. So 20 over minus 40 is minus 1/2. So M equals minus 1/2. So we now can say P equals A minus 1/2. Well, this really would be, in its formal form would be plus. So we're substituting in minus 1/2 for M, Q. So P equals A minus 1/2 Q. So we have this much now, right? Okay, with that, we have two variables, what we can three variables, P, A, and Q, but we know that we have two pairs of P's and Q's that go together. So we can just pick the first one. If P is equal to 100 equals A minus 1/2 Q of 60, we can now solve for A, which is pretty simple, right? So 1/2 of 60 is 30. So we have 100 equals A minus 30. Add 30 to both sides and we get 130 equals A. So now we know that M is minus 1/2 and A is 130. So we can say that P equals A 130 minus 1/2 Q. So that is the inverted demand curve for Molly's practice. So that's option C. Okay. Now, moving on to the next question. This is a thought question. UNH has an unexpected increase in enrollment. There are now more students in the community. This would result in a blank for Molly's services. Well, what we're looking for is and all the options say a right shift or a left shift of either the demand curve or the supply curve. Well, what we know is an increase in population results in an increase in demand. So that would be a right shift of Molly's demand curve from D1 to D2. because there are more students now in the community, there will be more people who want her services. So we would, at the same price, for example, we would go from Q1 to Q2. So if she continued to charge the same price, whatever that is, P1, she would go from getting a Q1 number of people who would like to use her services to Q2. So it is a right shift. Okay. Better Health and a text-based talk therapy service starts offering discounted pricing to UNH students. This would result in a blank for Molly's services. Well, it's going to be a left shift of the demand curve from D1 to D2 because Better Health is a substitute for Molly's services. And so some people will shift away from Molly and to Better Health when they reduce their price. So Better Health is always a substitute, right? It's talk-based therapy versus face-to-face therapy, which is what, presumably Molly, by default here, we're assuming Molly is a face-to-face standard traditional therapist. So text-based talk therapy is an inferior substitute, but it is a substitute. And so when the price of a substitute goes down, more people will shift their demand for the services to the substitute and reduce the demand for the primary service. Okay. Better Health is an example of a blank for Molly's services. And so we just talked about that. That is a substitute. So that's problem 4. Let me see. I should probably be sharing my screen. Okay. So I said problem 4, Better Health is an example of a blank for Molly's services. It's a substitute. All right. Problem 5. Brianna opens a durable medical equipment distributorship in Dover to sell and rent equipment to patients on the Seacoast. She finds when she sets her average price level at $800 per unit, she has a demand for 2,000 units. However, if she sets her price at $500 per unit, her demand is 5,000 units. All right, so let's stop the share. So this is, again, we're going to try to calculate the demand curve. So what we know is P and Q. So her first combination of price and quantity is a price of 800. She sells 2,000 at a price of 500. She sells 5,000. What is her inverted demand curve? Okay, so we know the inverted demand curve is going to have A plus M Q, right? And so we're going to solve for the slope first, for M first. So M is equal to P1 minus P2 over Q1 minus Q2, because P, right, and P is in the Y position and Q is in the X position. We're doing rise over run. So M is equal to P1, 800 minus 500 divided by 2,000 minus 5,000. We get 800 minus 500 is 300 divided by 2,000 minus 5,000 is minus 3,000, which is minus 1/10. So we know M is equal to 1/10. So we can say P is equal to A minus 1/10 Q. And now we just need to figure out what A is. And we can take either of the combinations. So let's take P of 500 equals A minus 1/10 times 5,000. Okay, so 500 equals A minus 1/10 of 5,000. is 500. Oh, I got a little mistake here. No, little brain lock there. Okay, how do we solve this? We add 500 to both sides. I was trying in my head to subtract 500 from both sides. So there you go. 1,000 equals A. So now we can say P equals 1,000 minus 1/10 Q. Okay, so that is the demand curve for Brianna's durable medical equipment service. Let's go back to sharing here. Okay. You don't need to see my video panel when I'm not using it. It just gets in the way. So now the Biden administration proposes legislation to provide a significant increase in Social Security benefits. Most of Brianna's clients are Social Security beneficiaries. This would cause a blank for Brianna's DME visit. All right, so if we go back here and we say, okay, so here's the demand curve, right? And most of her beneficiaries are Social Security most of her patients are Social Security beneficiaries, and they're going to get more Social Security payments. So they're getting more income. So what happens to the demand curve when your population gets more income? Well, it's able to afford more, right, at the same price. So at the same price, when we have more income, we want to consume more at the same price. And so we have a right shift of the demand curve. So the answer is a right shift of the demand curve. All right. Then it asks, I won't bother to flip here. The next question, problem 7 says, at a price of $50 per visit, when Molly's customers would have a consumer surplus of, right? So now we're back to Molly. So we said Molly's demand curve is 130 minus 1/2 Q. So P equals 130 minus 1/2 Q. So if we draw that, it looks like this, right? If we say, okay, this is P and this is Q. And if we said, well, when Q is equal to 0, what is the y-intercept for P for the price? Well, if Q is 0, right, if we're here, where does the demand curve cross the P axis? Well, it would, if Q is equal to 0, minus 1/2 times 0 is 0. So then the price would be 130. And where does it cross the Q axis or the X axis? Well, that's when P is equal to 0. So we'd say, okay, P is equal to 0, 0 equals 130 minus 1/2 Q. We would add 1/2 Q to both sides, right? And then to get rid of the Q, is get rid of the 1/2, we'd multiply both sides by 2. And so we'd get 260. And so we could draw a demand curve. It's like so, right? Now, the question assumes at a price of $50, so at a price of $50, so something like about a third of the way up, right? We don't have to be precise here. They would, based on this demand curve, you'd follow 50 over to the demand curve and to find the quantity, right? So at a price of 50, so 50 equals 130 minus 1/2 Q. And now we solve for Q. So we add 1/2 Q to both sides, subtract 50 from both sides. So we get 1/2 Q equals 130 minus 50 is 80. To get rid of the 1/2, we're going to multiply by 2. So we get Q equals 160. Okay. So now we know that the Q is 160, and we're trying to find the consumer surplus. Well, the consumer surplus is the area of the triangle above the price, but to the left, right, inside the demand curve. So it's this triangle here from the price up to the P-intercept and then down to the quantity. So what's the area of this triangle? Well, it's a height of 130 minus 50, right? This is the height times the length, 160, times 1/2, right? Because it's height base times height. Well, 1/2 base times height equals the area of a triangle. So 130 minus 50 is 80 times 160 times 1/2. Well, 160 times 1/2 is 80. 80 times 80 is 6,400. So that's the answer there. And then problem 8 goes back to Brianna's business. And same question, same kind of question. So we know that her demand curve is P is equal to 1,000 minus 1/10 Q. And the question is, at a price of 750, what would Brianna's customer surplus be? Consumer surplus be. Okay, so with a demand curve of P equals 1,000 minus 1/10 Q, we can draw her demand curve, P and Q, and we can say, okay, where's the P-intercept? Well, when Q is equal to 0, 1/10 of 0 is 0, so P is equal to 1,000. And then when P is equal to 0, 0 equals 1,000 minus 1/10 Q. We add 1/10 Q to both sides. And then we multiply by 10 to get rid of the 1/10, and we get 10,000. So 10,000. We can draw a line connecting. Okay, so that's pretty straightforward. And then the question is, at a price of 750 per unit, so about 3/4 of the way up, right? 750, we draw a line over here. Again, we're doing this just to visualize, not for precision measurements here. Okay, so we know when the price is 750, we want to know what is Q. Okay, so if we subtract 750 from both sides, we get 250 equals 1/10 Q. And then to get rid of the 1/10, we multiply both sides by 10, and we get 2,500 equals Q. So 2,500 so now 1/2 base times height, right? So we get 1/2, the base is 2,500, right? Because that's how wide the triangle is, times the height. The height is 1,000 minus 750, that's 250. I can't do that in my head, so I'm going to do 250 times 2,500 gives me 625 times 0.5 gives me 312,500. Okay, so that's the answer to 8 is 312,500. Share screen again for a second. Okay, so now we're on to number 9. As Molly contemplates the demand for her services, she considers how many clients she is willing to take on. At a price of $60 an hour, I'm going to jot that down. She's willing to take on a quantity of 20 clients. At a price of $80 an hour, she's willing to take on 40 clients. What is Molly's supply curve? Okay. So we jotted that information down, and we know that her supply curve is going to have a similar structure, just like the demand curve did. But supply curves, unlike demand curves, slope upward, right? So we just need to remember that. So we know we're looking for a positive slope this time rather than a negative slope. So that's something to just kind of keep in mind. So first thing we're going to do is solve for slope again. So we're going to use the p's first. So P1 minus P2 over Q1 minus Q2 is going to give us slope. So P1 is 60, P2 is 80. Excuse me. Q1 is 20. Q2 is 40. So 60 minus 80 is minus 20 over 20 minus 40 is minus 20. So minus 20 over minus 20 is plus 1. I made a mistake there. I was going to say that's not right. 60. Sorry. Didn't make a mistake, was looking at the wrong notes. Okay, so the slope is 1. Okay, so that's pretty simple. So P equals A plus Q. So now we just need to plug in one of these sets to solve for A. So we'll do 60 equals A plus 20. And then to solve for A, we just subtract 20 from both sides and we get A equals 40. Okay, so that means that the supply curve is P equals 40 plus Q. Okay, so that's the slope. Excuse me, that's the equation for this line. So it's got a slope of 1. Right? So supply curve. Okay. Now, question 10 says, assume Molly charges $75 an hour. What would her producer surplus be? Right. So now we take the supply curve and we're going to calculate her supply curve. Well, her supply curve is pretty straightforward here. If Q is equal to 0, right, then P is equal to 40. So that's about here. Sorry, P and Q. And then it doesn't have, well, it does have an x-intercept, but it'd be way over here. So we're looking here now, and we're going to roughly draw a line starting at 40, going up with a slope of 1. So slope equals 1, right? So that's what that looks like. So the price at 40, and if Molly charges $75 an hour, we can say that's like, about here. We can draw a line over and then down. Again, we're just drawing to help us think through the problem, right? And so we say, okay, at $75 an hour, what is the quantity? Well, price equals 75 equals 40 plus Q. Simple to solve this. You just subtract 40 from both sides and you get Q equals 35. Okay. So now we're going to calculate the area of the triangle that is formed by the, sorry, that should be supply, not demand, by the supply curve, right? And the price, the triangle that's below the price line and above the supply curve. So that's this there. So what's the area of that? Again, half base times height, right? So half, the base is 35. The height is 75 minus 40, 35 as well. So now we get, we can do 0.5 times 35 times 35, 612, 50. All right, for problem 12, Brianna is looking at her costs and estimates at a price of 600. She would be willing to sell a quantity of 2,500, and at a price of 740, she'd be willing to sell 3,200. So what is her inverted supply curve? Okay. So once again, P equals Q, A plus MQ, and M is equal to P1 minus P2 over Q1 minus Q2. P1 equals 600 minus 740. Q1 is 2,500 and Q2 is 3,200. So 600 minus 740 is minus 140 divided by 2,500 minus 3,200 is minus 700. So the negatives cancel. So then we get 140 divided by 700 equals 0.2 or 1/5. So we know that. Now we know P is equal to A plus 1/5 Q. So now we just need to plug in one of these pairs. There's 1 and 2, right? One of these pairs. So we can just do the first one. 600 equals A plus 1/5 times 2,500. Well, 1/5 of 2,500 is 500. So 600 minus 500, A equals 100. Okay, so now we know, plugging in 100 here, we know the supply curve then is P equals 100 plus 1/5 Q. So that's the answer to 11, 100 plus 1/5 Q. Now, the next question is, given the supply curve you calculated above, at a price of 650, what would Brianna's producer surplus be? All right, so we need to draw her supply curve, right? It has a, so we have P equals 100 plus 1/5 Q. So when Q is 0, P is equal to 100. So that'll be our starting point. And then we said, and so we know it goes up at 1/5. It's a pretty flat line like that. So when we get up to 650, I'm just going to draw like so. Definitely not, to scale here. What is that quantity going to be? So at a price of 650, 100 plus 1/5 Q. So minus 100 is 550 equals 1/5 Q. 0.2 time, excuse me. So 5 times 550. So get rid of the 1/5. We're going to do 5 times 550 gives us a Q of 2750. So we know that's 2750. And now we're going to, this is the producer surplus. It's the area above the supply curve, but below the price. So 1/2 base times height. Right. So 1/2 the base is the width of the triangle is 2750. And the height is 650 minus 100 or 550. So 2750 times 550 times 1/2 times 0.5 gives us 756,250. So that is the answer to problem 12. Problem 13. Okay, so problem 13, because of inflation, many of the components that go into the DME that Brianna sells are increasing in cost. This would cause a what for Brianna's DME business? All right, well, we're talking about the components or inputs into her supply, into her decisions about supplying, right? So price and quantity. So when things get more expensive, right, let's assume we were here, right? When things get more expensive for the same quantity, right? So let's say, 2750, let's say, right? And we had 650 here. I guess I could have just used that one. Her inputs now are more expensive than they were because of inflation. So when she goes to buy the things that she's going to sell at retail, they're more expensive. Well, what does that mean? Well, if she wants to sell 2750 units now, she's going to have to charge a higher price. right? Well, what that represents is a left shift of the supply curve, right? Regardless of the quantity she wants to sell, she's going to have to sell it at a higher price than she used to. So whatever quantity you choose, she's going to sell it at a higher price. That's a left or up shift, however you want to look at it. Uh, okay. And problem 14, in order to fund an increase in inpatient mental health beds, the state of New Hampshire passes a $10 per client tax on providers of outpatient mental health care payable by the provider. This would result or would cause a blank. It's going to be, so now let me go back to my. So now we're back to Molly, right? Molly had a supply curve of 40 P equals 40 plus Q, right? And so now the state is going to charge her a $10 per client tax. So if she's going to treat a client now, she has to, every time she treats a client, she has to give the state $10. Well, what is that going to do? Well, she's going to want to raise her. So let's say she was treating 10 clients. So that would be P equals 40 plus 10, or P equals 50. So at 10 clients, her price per client would have been $50. In order to make herself whole, if she wants to keep treating 10 clients, she's going to have to charge the $50 plus an additional $10 per client, right? If she did, say, 12 clients, it would be P equals 40 plus 12, or $52. So at 12 clients, she would have been at $52. But right, when the state says, hey, every time you see a patient, you got to give us $10, instead of charging $52 at 12 clients, she would have to charge $62. So what's that doing? Well, that's shifting her curve to the left, raising her or up, right? So effectively, the P-intercept is being increased by the amount of the tax. So we could effectively say the new tax price is 40 plus 10 plus Q, or 50 plus Q, right? So when the government taxes Molly's business, she has to raise prices across the board by $10. So it's a left shift or an upshift of the supply curve by $10. So why am I saying, you're saying, well, obviously it's an upshift. Well, actually, let me draw that a little more to scale, just for so you can see why I'm saying it's a left shift. You can think of it as an upshift, but let's say you had that supply curve at 40, right, with a slope of 1. It's a little shallow for a slope of 1, but again, we're not drawing for precision here. If it were possible to have negative quantity, which of course it isn't with patients, you can't have negative patients, you could draw that line backward like so, and you'd have some negative quantity. And so when I increase the intercept to 50, but I keep the slope the same, it's a parallel line. So this line and this line are parallel, right? That double tick mark means these two lines are parallel. I could extrapolate the line back, and the x-intercept or q-intercept is a left shift. And that's what we're meaning when I say a left shift, I mean the line, the x-intercept, or in this case, the q-intercept, has moved to the left. It also, of course, is visually a upshift. So either one, if you say it'll shift the curve up, I'm not going to say no, that's wrong. But when I say left shift, that's what I mean. Okay. Last few. All right. Given the demand and supply curves for Molly's practice, what is the equilibrium number of clients she will take on? All right. So we said that Molly's demand curve is P equals 130 minus 1/2 Q, and her supply curve is P equals 40 plus Q. So if we were to draw those two curves, her demand curve goes down like so, and her from 130, right? And her supply curve starts at 40 and goes up at a slope of 1. And so where the supply and demand curves intercept is the equilibrium point. So this is the equilibrium quantity, and this is the equilibrium price. So what we need to do is find the equilibrium quantity and price that sets the supply and demand equal to each other. That's how you find that intersection, right? So we're going to set these two equations equal to each other. So we're going to, since we know we have them both in P form, we will just say 130 minus 1/2 Q, so that's the demand curve, is equal to 40 plus Q, the supply curve. And this Q, when we solve for Q, will give us the QE. So we're going to subtract 40 from both sides. We get 90, add a half to both sides, and we get 3 over 2Q. Okay, so now we've reduced it. We've consolidated the variables. We're going to multiply both sides by 2/3 to get rid of the 3 halves. 2/3 of 90 is 60 equals Q. So QE is 60. And if we know QE is 60, we can take QE and plug it into either one of these equations. I'm going to do both just to prove that to you, okay? So if I take 60 and plug it into the demand curve, I get P equals 130 minus 1/2 times 60. 1/2 of 60 is 30. 130 minus 30 equals 100. Over here, if I take P equals 40 plus 60, I get 100. So the equilibrium price is 100. The equilibrium quantity is 60. So that solves problems 15 and 16. And then 17 basically says to do the same thing for Brianna's business. So rather than messing around with that, I'm just going to pull them up. Okay, for problem 17 and 18, we're dealing with Brianna's business, right? So same thing. We know her demand curve is 1,000 minus 1/10 Q. Her supply curve is 1,000 plus 1/5 Q. So demand, right? Supply, it's about 100. That's 1,000. It's not about 100. It is 100, right? And so we want to find, this is our price and our quantity. So we want to find our equilibrium quantity, our equilibrium price. This is the equilibrium point. How do we find it? We set the two equations equal to each other. That should be 100, not 1,000. Plus 1/5 Q. That'll throw me all off. All right, so now we consolidate terms, subtract 100 from both sides. We get 900. Add 1/10 to both sides to get rid of the 1/10. 1/10 Q rather, and we get 3/10 Q because 1/5 is equal to 2/10. So if I add 1/10 Q to 2/10 Q, I get 3/10 Q. And then to get rid of the 3/10, I multiply times 10 over 3 times 10 over 3. And I get Q is equal to 10 times 9,000 is 900 is 9,000. 9,000 divided by 3 is 3,000. So Q equals 3,000. So if Q equals 3,000, I can plug that back in here. On the demand side, I get P is 1,000 minus 1/10 times 3,000. 1/10 of 3,000 is 300. 1,000 minus 300 is 700. Over here, I take P equals 100. 100. I really want to make that 1,000. 100 plus 1/5 times 3,000. 1/5 of 3,000 is 600. 600 plus 100 is 700. So you can see they both. So the answer is the equilibrium price is 700. The equilibrium quantity is 3,000. And that is all for problem sets 3 and 4.